Mentioned it briefly. Tom Wolff, who's graduated last year, 2 years ago. Last year. See, the time just flies.
Yeah, I know.
Tom graduated as well. Tom is now a postdoc at Northwestern, working at the Network Canvas Lab with Michelle and a group of remarkable folks there who also have, I think, you all might have met here at DIS. So if you learn nothing, maybe at least find a postdoc, Spencer, who will give you a job. Tom's work is, he's one of the best coders in the business. He's been deep in the weeds of network analysis. And this project we've engaged is, we call it IDEANET, which he's going to describe. The joke version of it, this is analyst in a box. We hope to sort of take a lot of what we're teaching you in this class and distill it down to a simplified interface that lets you get the work done and create a bunch of these things in the process. His own work is really remarkable, that his dissertation was on intervention communities and dynamic networks and understanding the involvement and movement of these things. And so, thanks, Tom, for doing this. Appreciate it.
Yeah, thanks, and thanks to you, Jim, because a lot of the discussion of the repository there in that last conversation had some slides to introduce it, but the basics were covered there, right? But the IDEANET project, which is an NSF project we've been involved in, a lot of the crew here involved, Gabe, John, Emily, Dana, right? It's motivated by this idea, as was raised during a question in the last talk about this idea of balancing reproducibility in network research with data security, right? And so, like as said before, we're hoping to launch this secure data repository for sharing network data between researchers and across institutions. But there's this other component, right, to reproducibility with network data, which is network analysis is increasingly popular. When Jim showed some graphs, and you're all here, right? Like we all know about the growing popularity of network analysis, and related to that, as the popularity of these methods has grown, so too has the number of tools available and the way that things are measured. And so this ends up creating some pitfalls, right? Where which tool do I use? Sometimes some tools are better suited to certain tasks than others, right? How do you balance these things? The other thing is that as different people have developed their own tools, much in the same way that we much in the same way that we talked about people developing their own centrality measures for different purposes. Sometimes different tools out there will measure ostensibly the same measure or same metric differently, and then this can lead to some reproducibility issues where maybe you get access to the same data as this previous study did, but then when you run it through, it doesn't give the same numbers, and there's some confusion there. So as a kind of companion product to this data repository that we're developing, we've been building an R package that kind of aims to take the best out of different network tools available and consolidate them in a very entry-level user-facing package, right? And our aim is that whereas a lot of times when you're doing network analysis in R, and we'll see this in both tutorials we've seen before and later on in the week, right? There can be these many steps. We're trying to streamline this as much as possible. Now there are some caveats, right? We're currently readying this for release on CRAN as a formal package. The need to balance, getting something actually out the door with, as far as like the full range of network analysis methods out there. We don't cover everything. We've got plans to add more features in the future. Also, right, there are certain types of measures that one-size-fits-all tool is better suited to. So things like measuring a node's centrality, right, or centralization or cohesion in a graph. Those are measures that can generalize across a network. But other times we might have measures that depend specifically on attributes of nodes, right? And IDEANET isn't aiming to cover those as much, just because you might need to custom tailor those measures to the specific setting that you're working with. So on the Google Drive, there's the folder for this presentation. I've arranged it so that there's the R Markdown, which is here. If for some reason it's not running, I've already knit this Markdown into an HTML, so you can just follow along in the output. Presents nicely there. And there is a lot of things in the text here. I won't go verbatim with the text. A lot of it's written there just for kind of future reference and a refresher. But to start, there are a variety of ways of installing the IDEANET package that we've developed. The most straightforward way, which in the install script we sent to everybody, is via GitHub. Just running this script will download the latest version of the package and all of its documentation. Hopefully you should have had that, done that ahead of time. Another thing, that, like if for some reason you're having issues installing from the GitHub page, I have included a source file of the latest version of the package in that folder on the Google Drive, and if you just run this code, it'll install it, and in fact, it'll install it quicker. So as we've talked about, right, network data can be stored in a variety of formats. Most common are a combination of a node list and an edge list, or an adjacency matrix. And on top of that, and I alluded to this a little bit earlier, given the variety of software out there for analyzing network data, whether it be modules or libraries or packages in existing programming languages or standalone applications, network data in these formats can also be stored in a variety of different file formats. And that can lead to some difficulties with accessibility and reproducibility in terms of just how do I get this data open in R. So the first feature we have within the IDEANET package is this function we call netread. And it's designed to take a variety of different network data storage formats and turn them into like a very nice R-friendly edge list that not only could you use in other functions within this package, but also just within R in general. Right now, netread supports just standard CSV Excel files in the way that you formatted for edge lists and adjacency matrices and adjacency lists. But we also support the reading of IDEANET DL files. For those of you less familiar, and honestly, I'm very much an R guy, so if there's some details about the software that I'm missing on, some of the more experienced folks can feel free to chime in. But IDEANET is a Windows-only application. It's generally very good at measuring centrality, structural features, community detection, role analysis. The drawback to IDEANET, aside from Windows only, is it costs money, right? And for young, early career folks, right, free and open sources is always nicer. But fortunately, IDEANET data are usually stored in these DL files, and by using the netread function, and here it's just set up very simply, you put in the direct, the location of the DL file, and you specify that it's a IDEANET file with the file type argument. You see here, it just very quickly read in the data, and here it is as a nicely formatted edge list where we have our we have our sender column, we have our receiver column, and then any of the other edge level attributes, right, just as they were organized within that IDEANET file, are presented as their own columns. Similarly, we provide support for files that are designed for PIAC. PIAC is a free application, unlike IDEANET, but it is Windows only as well. But PIAC tends to be the go-to software application for dealing with like very large networks. And in fact, there are different versions of PIAC called like PIAC, PIAC XL, PIAC XXL, right? Like it is like its big draw is scale. But nonetheless, if for some reason you're wanting to work in R and your collaborator's giving you data stored for PIAC, similarly, you just specify the location of the file, specify that it's a PIAC file. And here in this example, sorry, I need to, there we go. And here we've read in, an example of a PIAC file, and this PIAC file happens to contain both a node list and an edge list. And similarly, it's extracted all the information we would need to proceed. So that's just a matter of reading in data from other sources. But the real fun part of the IDEANET package is the streamlined processing and analysis of relational data. And for sociocentric networks, and here I'm just going to focus on sociocentric networks that are just single relation types, the real core of this analysis is in a function we call netwrite. Here I'm going to just demonstrate what netwrite looks like. We have some example data sets native, just stored within the package when you install. This is another synthetic, simulated @health data set here. And if we just look, right, it's this is the similar to what Leanne showed in her presentation. Similar structure, senders and receivers of ties. Here we have some attributes of node IDs, their grade level, their racial categorization, and their sex. But the netwrite function will take these two data sets or an adjacency matrix and just in a single function do a lot of the really basic level network analysis that you would want. A bit of a trade-off here is that relative to some other R functions, right? You may need to specify more arguments, but it really depends on just sort of the complexity of your network, right? So the more distinct features of your network, right, like directionality of ties, and if you have multiple tie types, right, the more of these arguments you may have to specify. One thing I should say is that while we might not be using all of these arguments here in some of these examples, they're detailed here. Also, the package already comes with, I would say, fairly thorough documentation to walk you through all of this. But let's just go ahead and show how we would use netwrite to process, and get a pretty good starting point for analyzing this high school network. So here, within the netwrite function, we're going to specify the type of data we're working with. Here we have an edge list, right? If we have a node list, and this is similar to iGraph's graph from data frame function, right? If there's a node list available, we want to inform what that node list is and what the column within that node list containing the unique node identifiers. Then we want to specify from the edge list which columns are the senders and receivers of ties. We're going to specify that this is a directed network. Among other outputs from netwrite, it creates an iGraph object in case you want to use that later. And this is just telling us what to name the iGraph object. And then this shiny argument is for a little fun thing I've included at the end. I won't spoil the surprise yet. So we're going to run this. And this is a fairly small network, so it ran quickly, but depending on the size of your network, right, you may have to wait a bit, because this is, as you're going to see, this is doing a lot. This one function is doing a lot. Sometimes you'll get a list of warnings. One thing to bear in mind, and this is not just when using kind of very generalizable tool like this, but whenever you're doing network analysis, similar to what Jim was saying about centrality measures and like what do they mean in terms of in terms of the substantive setting of your network. Similarly, right, like the way certain measures are calculated might not be compatible with certain structural features of your network. So for instance, with something like eigenvector centrality or Bonacide's centrality, right? Like a lot of times those measures will kind of assume like one single connected component. And if you have isolated components from each other, right, depending on the tool that you're using, you might get some messy numbers or missing values because it doesn't really know what to do with a network structure like that. To the best of our ability, as we've curated the measurement of certain metrics from different sources, we provide a pretty extensive set of warnings about, hey, as we noticed this feature about your network, and it has implications for how this measure is generated. Bear that in mind as you're looking at the output. Now, one thing, I don't know, how many of you are, as far as familiar with R, like work with lists as a class of object? Okay, we've got a couple people. This is something that it gets. Yeah, for a lot of folks new to R, lists are not something that's as intuitively accessible. Because of the way R packages are designed to work, where the idea is like good programming practices, you put in a set of inputs and a function's supposed to give one output, right? By default, netwrite creates several outputs, but they're all stored in a single list object. However, R has this list2environment function that will take everything within a list object. In this case, we've called it NW for NetWrite and Faux Mesa, which is the high school network. And we're going to just split this up into the global environment. And so we can see the number of objects here, right, in our environment grew quite a bit. That's because NetWrite is, created a lot of things for us to look at right away. And let's go ahead and take a look at what it creates. So NetWrite, the NetWrite function, when you're giving it a sociocentric network, it's creating measures both that are at the node level, right, and at the structural level, right? And we just talked about, each of those, like centrality measures versus cohesion measures. It's generating a whole suite of those and splitting it up into different objects. So here, just to start, NetWrite produces a summary, a little visualization here that provides some system-level summaries, right? So you can see here number of weak components, which I don't think we've talked about. We haven't differentiated between component types yet, but things like degree assortativity, transitivity, right? Here we have the just a visualization of the degree distribution across the network, clustering, and the average path length. Now this, as far as like a quick glance of just making sense of your network and its structural properties, this is nice. But, suppose that you're really interested in some structural feature that isn't covered in this visualization. Luckily, we have a whole data frame here called system level measures, and we tried to be as thorough as possible, right? This is going to tell you, right, like whether or not the graph is directed, right, how many isolates are in there, the number of components as defined by certain conditions. As Jim said, he loves triads, so we've got the whole number of different types of triads in there, right? We call it the triad census. We have clustering. I would say, a lot of times there are debates within network science about how, when you're introducing your data set, you should describe the structural properties of the overall network as kind of like descriptive statistics. And I think, and people debate over like what are the must-haves. Our goal here is like, we're hoping once you run this, like whatever your journal or your community demands, like, use that to describe your data, like we've generated that for you, right? The other nice thing is we're not gonna get into multi-relational networks, but like this will also, like it'll calculate these for the aggregate graph, it'll also break it down by relationship type. So this is a nice, it's, obviously, if you venture into more complicated territory and need to do some more specific things, like we might not be able to handle it. But as a starting point, I like to think that we're offering folks a lot to start with. On the subject of we can't cover everything, right? We do take the network you fed in, and we do create an iGraph object, right? So if you do need to go back to some of the more established tools, right, that have more involved processes, right? You have the means to just get started, to take what we have and expand on it using an iGraph object. We also include the iGraph object, right, because it's often, iGraph objects are typically the most straightforward starting point for visualizing networks within R. And as you can see here, I've taken the high school here, and I've colored the nodes by grade. Gabe is going to go into more detail about best practices for visualization of networks later this week. We also create iGraph objects for the largest components within the network, right? So if you're just interested in sort of like the subsets of network of the network you're working with, we also provide that. We also have a reformatted edge list. In the past, the iGraph package has, because it was originally developed in Python, it had some issues where like it used zero indexing like Python did, and when you were working with R, it could lead issues. Like part of what's going on under the hood with NetWrite is we create a new set of ID numbers to like avoid that issue of, that issue ever possibly arising. So we have the edge list here. Now let's move on to, moving on to the node level, right? And I'll just open node measures here. It's taking, basically, when you give NetWrite a node list, right, it's going to keep those original node level attributes. But if we go here, right, all of the all of the node level measures that we talked about earlier today, and a few more, right, are being calculated, and it's appended to that original node list. So as far as for, if you're just thinking about like basic regression models based on, structural position within the network, right, we're giving you a lot of the basic starting points that you would be generating yourself over maybe like 50 lines of code or something, just right out the gate. And we also have, I was intrigued by this today, Jim, with the reminder of the difference between Bonasich with regular weights and with negative weights, and we provide both right out the gate. I think that's not always that's not always as immediately accessible. So I'm proud of ourselves for that. Just like with the system level plot, we also have a kind of summary plot to show the distribution of different centrality scores, for nodes in the network. So that's also quite nice. But that's the core netwrite function in a nutshell, and it offers a lot. And it's we're proud of that. It's also very standardized, right? So not only if all goes well and we have our secure data repository and people can access the same data sets, if they're also using the IDEANET package in tandem with it, right, that's going to further ensure reproducibility as the same tools are being applied to the same data, and we've curated the measures and verified their accuracy. Just to show, to prove that we also support adjacency matrices, we have a little example of, this is a completely fictional network, but it's a little adjacency matrix that Jim designed that contains every possible type of triad that can exist in a directed network. It's actually it's a very good data set for testing networks, and I wish I had known about it years ago in grad school. It's a good methods object. But here here running netwrite on this adjacency matrix. Note that we don't have a node list here. But despite the many arguments that netwrite can take, we're only using 4 here. We're telling it that it's an adjacency matrix. We're specifying what the matrix is. We're saying that it's true, and then we're naming that iGraph object again. And once more, we have the list and we split in the global environment. I'm just going to show real quick. This is the network, the iGraph object plotted. But similarly, right, we can now open the system level measures, right, and it's giving us that same information for that little adjacency matrix network. I designed, part of this was due for time because I thought I'd be talking about the data repository more. But as far as other features, we do support, if you have an edge list with multiple relation types, the netwrite function will process that the same way. It will calculate, like I said, for the system level measures, it'll provide measures for each subset of relationship type. It also does that at the node level. So let's say you have family and friendship relations, and you're interested in the betweenness centrality in just the friendship network. It's going to give you betweenness centrality for friendship, for family, for the whole network. And that gives you a lot of power and a lot of different variables that you could possibly use in modeling. I didn't want to inundate you with too much, so I didn't include the examples for that. However, a lot of this tutorial and what I've written here is adapted from the documentation vignettes we actually have in the IDEANET package here. You can access them by just running the vignette function, specifying the name of the vignette and then specifying it's in the IDEANET package. But if I just run this, we can see, right, we have a whole extensive, a lot of what we covered, but then going into multi-relational networks and community detection. The idea is our target audience is folks who like many of you are new to network analysis, and right, we want this to also be a tool to help familiarize folks with network analysis, and so our documentation reflects that. Like we're trying to walk folks through as many steps as possible. Other things I want to say before we get to this last section. In the last year, we've added functionality for ego network analysis as well. And so we have a couple of features. One, the core. This is netWrite. We have a function called ego netWrite that once you pass in a node list, an alters list, and an alter edge list. Gabe later in the week will talk about these kinds of data structures. But it's going to similarly give you a data set level summary of what the typical ego network in your data set looks like. It's going to provide system level summaries for each of the individual networks, and then it's also going to create node level summaries for all the alters in the networks, right? With the same philosophy in mind that we're trying to give you as many of the basic measures as possible for analysis, so that when you're modeling, right, you don't have to generate all of those, spend a week of coding to generate a lot of the basics. Another thing I will say is we also have a function that we've just recently really refined, that if you have an ego network data set that is in that very wide format, right, we're going to reshape it into something that's a lot friendlier. That's also something we'll talk about tomorrow. The aim here, right, has been to minimize the amount of coding that folks new to network analysis have to do. But what if you just don't want to do any coding at all, right? Like, it's tedious, maybe you don't need it, and we made you install R, but maybe you'd rather just avoid it entirely. Fortunately for those folks, the IDEANET package also offers a Shiny-based graphic user interface. I can't take too much credit for this. Emily in the back has been absolutely vital to developing this, and it's taking it's a nice interactive implementation of the functions I've just shown you in a much easier and intuitive way. And I'm just going to illustrate this real quick. You can choose edge lists or adjacency matrices here. There's some formatting little bits here, but you just pass in a CSV of an edge list. If you have a node list, you pass in a CSV of a node list. And just going, as you use this app, you go to the right over these different tabs, and it kind of goes through the process of like loading in data, specifying what these, what the data, the specific variables mean. So over here in the process tab, we're just going to choose the sender and receiver IDs in our network. We can specify that the network's directed. This particular network's not multi-relational. And then over here, we specify similar aspects about our node level data. If later on in visualization you have certain variables that you think would be relevant to coloring nodes or something like that, you can specify this here. And then once you've set all of this up, you can just go to the Visualize tab. And there you go. You've got the network here. And there's all sorts of customizability here, right? You can scale this up and down. If you don't want isolates, sometimes isolates can be troublesome for your layouts. You can get rid of those. If you have duplicate edges or loops, similarly. Any of the layout algorithms that are offered by iGraph, you can quickly just choose. So if you want a sphere for some reason, Früchterman Rheingold is generally what I use. We also offer node sizing by a few different centrality measures here. And if you want to change kind of like the scale and the disparity of it, right, we have a slider for that. And then as I showed in the last tab, we specified some node features that we thought might be interesting for coloring. You just choose the variable, and then we have some color palettes available. Right here, we're coloring by grade. We have a little legend here, and this is really neat. This is built off an R package called VizNetwork that has a kind of interactive HTML5 element to it. Once you click toggle interactivity, you can highlight a node and it'll show its ego network. And if you have a central, suppose like I have this central node here and I really want it to pop out, but your standard network layout algorithm is going to place it here, I can just click and drag it out here. So if you want to do any slight customizations to make things a little bit more intuitive to look at, it offers you that ability. And And then the other thing is up here, you can specify your file format. And then once you've customized this as you see fit, you can just click it and just save it as a PNG or a PDF. Yeah. Again, I wasn't as essential to the actual development of this app, so I can't take credit for it. But it is quite convenient and cool. We have a tab here, the visualizations we talked about before, both at the system and node level, as far as distributions and very basic measures are also there. This tab is great for the folks who want to avoid coding entirely. That data frame of node level measures with all the centrality measures you might want and need for regression. This is that table here. If you want to quickly look at it, right, you can select and isolate different variables, right, to get a sense of their distribution. But we've also added a little feature here to generate quick visualizations for univariate and bivariate statistics. So here, let's look at the inbound closeness centrality and the distribution of that. We have it as a histogram, a box plot, or a density plot. But then we also can choose a second variable, right? So closeness in, and just for, I'm going to do closeness out. And then here we can select a scatter plot. And any sort of like exploratory analysis and visualization that you would often do when you're just starting with the data set, you can do right here within the app. And the other convenient thing is you can download the generated set of node level measures and all centrality as a CSV. So if you want to, if for some reason, like suppose you're a Stata person. I'm not, but suppose you're a Stata person and you want to do most of your modeling in Stata, but you don't want to generate all this network measures. You could use this Shiny app, get your centrality measures, export it to this CSV, and then go use it in some other software. And then the last thing, and I didn't cover this in part because some of this is going to be addressed later on in the week, but we also have been adding in modules for more advanced methodological techniques. And currently we have modules for MRQAP, which I don't know if we're going to go into later on in the modeling. We will. And then positional or role analysis. We touched on that a bit with the example of the family and the children and the different configurations of relationships they had. But there are methods specifically for kind of extracting role positions within networks. And we've built a very streamlined tool for that that's often lacking in a lot of software tools out there for network analysis. But I won't go into too much detail with those since that's going to be covered later in the week. And just one, I just realized I forgot one thing. You don't just have to color on node level features here. We're going to talk more about community detection later in the week, but one of the options you have for coloring nodes in your visualization here is where nodes fall within specific clusters or communities in the network as detected by various different algorithms. So that is a very quick and kind of high-level overview of the IDEANET package. The one thing I would like to close on is help us help you. We are gearing this for CRAN release. We've built a small community of folks who've tested this out. We've gotten great feedback about people trying out this tool and saying like, this made my dissertation so much easier, right? But the help goes both ways, right? Because in those early stages, right, we designed this and tested it on data sets that were available to us, and we made certain assumptions, right? But then as other people tested it out, right, we encountered snags and use cases and bugs, right? The more people try this out and adopt it, the better we can make it. And we've already had some really valuable exchanges, just even in the last year with developing it. So I highly encourage you to try this out, over this week and then with your projects. And I have my email address at the bottom of that R markdown. Like, do not hesitate to email me. Like, putting out fires in this is, not that there are too many fires anymore, but once upon a time, putting out fires was like my #1 priority for a while, right? So I am quick to respond. And I'm always eager to kind of figure out a new methodological puzzle to get working in here. Yeah.
Where do we find this shiny tool?
Oh, it's already included in the package. If you've installed the package, you just run the IDEANET viz function without any arguments, and it's just going to open that app for you. Yeah.
Also, why does 1 and 4 have the same colors?
Part of that's if you look here, they're slightly different. It's just the particular rainbow palette just doesn't have a great differentiation. If we changed it over to like a heat map, I mean, it's just that's one of those things that, like, when you're doing visualization, sometimes something that works for one use case doesn't work for another, and just trying different things out. But that is the when it comes to kind of the philosophy of this package. I know as a graduate student, I had many experiences where I had an idea, like the theoretical idea I wanted to test out, and I'd spend, a week writing the code to do it, and it was a dud idea, right? And I'm like, shoot, I wish I hadn't done that. I mean, the nice thing about this, like, a lot of this is built on those failures I had in the past, where then I turned it into a streamlined process so that, like, in the future when we have ideas we want to test out, right, you don't have to spend that time anymore, right? And I think this is also where the future is going, with just Jim showed with the ChatGPT example, right? Like, the more, the better we can get with technology to automate these processes, assuming that they're reliable, the more time we have for actual theory testing, which is, for most of us, why we get into this game. Yes?
I just want to say thank you.
It's not just me. It's not just me. The whole team.
The whole time I'm just like, wow. I'm just nerding out, and I wish I had this for my dissertation last year. So I just feel like it's going to be a game changer. I spent so much time going through different programs to find just the right statistic to look for, and so just thank you for trying to make this easier. I work a lot with qualitative researchers who are interested in using network visualizations. Can you get to IDEANET without going into R?
You would need R to install it, but as far as this visualizer, once you had R installed, then you could just run it, and they don't. The only line of code they would need to run it is just that IDEANET viz function. Yeah.
And then lastly, bipartite networks.
So that's a coming feature. I think that's honestly once we get this on Crane, that is literally the first thing we're working on. It's been on the docket for a while. Yeah.
Actually, going on to the prior comment, someone new to this field, figure out the path of least resistance.
Yeah.
So loading all these packages over the course of the week, do you recommend starting and just trying to figure out an IDEANET, or is there a path to best to start out on?
I think so. I sort of alluded to sort of my view of it, and if you asked different people here over the course of the week, they might differ with me. I think IDEANET, a really great use for IDEANET is step one, right? We know that degree, betweenness, eigenvector centrality. Those are often things we kind of take for granted that we extract at the beginning of the process. This is great for you're doing that. You don't quite know with your project yet if you need to do something a bit more tailored. I would start with that. But I think as we I think many of us have experienced our academic projects often end up being more complicated than we think, right? And we all fall down our very niche and specific rabbit holes, right? Like for instance, some of the dissertation stuff that I did that Jim was describing, right, is very momentary. We call them relational events, networks of momentary interactions, right? That's, there's been great developments in that over the last 10, 15 years, but that's still very niche. It's not the sort of thing that your starting point, right? I would say start with this. Do your modeling. See if that's all you. In some cases, right? There are some ego network analysis projects that I've talked to students about where what we offer in EgoNet, right? Covers the basics of what they need, and there's not too much further from that. But inevitably there's always something a little extra that you need to do. the time you save here will help you kind of learn what specific tasks you need for later on. That's my philosophy with it, at least.
And I might say that one of the nice things about starting with IDEANET is that at a minimum, you'll get an iGraph object out of it without having to do all this specification there, and then you can go figure out what to do with an iGraph and use some other kind of metric. So we haven't created it here for you, and you have the tool now to watch. Once you close this thing down, you go into R, use any of the other tools, data structure, really you can create.
And I'd like to add that, like, on the ego network side, right? Like, one of the neat things about egocentric data that you know, might be touched on later in the week, but there have been some advances. We do this you know, in my work over at Northwestern, we do this with modeling HIV transmission, right? But there are methods out there. There are methods and tools out there for taking a representative sample of egocentric networks and then simulating global network structures, and then using that for simulating disease transmission. We don't offer that in here. However, the eGOR package, which is an R package specifically for ego network analysis, the objects that it creates, or you know, its core kind of R object, is very compatible with the tools out there in R for simulating those broader structures. And while EgoNetWrite isn't as convertible to that, like, you can specify an argument in EgoNetWrite to generate from your data set the eGOR object that you can then pass to simulate those things, right? We know, so for instance, like, we're going to talk about exponential random graph models later in the week, right? Like, the tools out there for ergoms, right, are like perfectly fine. In fact, like, the ergom package itself has a Shiny app like this to fit ergoms that, like, if we added it in there, it would be redundant. We know we can't cover everything, and we also know that there are tools out there that we fully trust. And so oftentimes, when we recognize what we do trust and, you know, and think is intuitive, our goal is to kind of set you up for using those things, you know, those more advanced things. Right? This is meant to be the jumping off point. Like I said, if you have questions later on and as you try it out, you know, I am happy to talk about this indefinitely.
I have one other way you can use it for training that I've done is you can be fairly certain that the numbers in there are probably right. And so when you're learning how to do a measure by hand in R, if you eventually want to do that and you want to write the formula, it's a nice thing to check against. You're like, how close to the truth am I? And I've been doing that for the last 6 months.
I will say, yeah. I will say when we developed, you know, and I wasn't here at the genesis of this project. A lot of the real foundations John Morgan built, but you know, when I came on the project, it was explained to me that, like, the target audience for this is, you know, folks like you who are new to network analysis and have health applications. But it has also extended to, because of the accessibility that we're trying to promote here, you know, a new goal has sort of emerged of using this as a teaching tool. And I actually, like, in the past year, I've linked up with one of my old professors from undergrad, and we redesigned his networks course and had this as like a teaching tool. And we're we're always thinking about how to refine it year after year, right? Like as I said before, I want this to be like a launching off point for networks in R. Like, I do also want this to be a pedagogical tool. And as we expand our documentation, right? Like, we want to make it that you can use this as a reference manual for not just R, you know, like an R package, but also just for network analysis, and kind of reminding yourself, like, you know, why do we measure these things and how do we use this? Which is also to say, if you teach a class on networks one day and want to use this as a teaching thing, also feel free to reach out.
All right. I think before I let Tom go away, I do want to point out that this work is the original visualizer work. The IDEANET is an NSF project that myself, Peter Muka, Dana, our PIs and co-PIs on. But the Shiny app was originally, the first version of it was created by Kieran Gilley, who is an undergraduate. And now Emily Harity has done most of the research and just graduated with her bachelor's engagement. Student-driven project to make a really useful tool, and then, again, the other artists are, professionals, John, Gabe, and Tom, Ross, and Madeline, involved with various other pieces of this. So it's really been a remarkable project, and I really hope, like I said, that the next part of this is that it will be automatically between this tool to the secure data repository. So you should be able to have it integrated with that. That's what IDEANET stands for, integrated data.
Exchange and analysis for networks. I should have led with that.
So the integration is to go to this archive eventually. And so it would be really useful for us. If you do use this tool, you'll let us know how it worked and what we need to fix and how to make it better. And I think it can hopefully be a solution to some of the real life problems.
Historically, if you point out an issue with me, we patch it up within like 3 days.
All right, thank you, Tom.